right, let's go back to social media. What kind of questions do we have waiting for
All right.
us?
Well, we got some more questions here, and if I can get my inbox to come up here. There we go. All right. So this is an interesting. This is a math midpoint formula, and let's see.
we just did that.
Oh
one,
no,
actually.
we did do.
Yeah.
You're right. Sorry. How about this one? This one has a parallel lines cut by a transverse line.
I was peeking at this one in advance. I guess I can take it.
Oh, okay. All right.
I'm noticing Matt Damon has a lot of math and science questions. Do you think it's because of his previous roles in Interstellar and The
I bet
Martian
it
that got
is.
him more
I bet
interested in science?
I thought wasn't Matt Damon the one who did the like really complicated?
Yeah, he did the Goodwill Hunting
in
where he
Goodwill
wrote it on
Hunting.
the.
He
Oh,
does the
Goodwill
super
Hunting
complicated
too,
math. That's
yeah.
why I don't
He's
understand why he
researching
needs.
for his movie roles.
Oh, there we go.
Yeah,
There we
He
go.
can be a
I heard
genius.
that.
He's
Mother-
playing a 7th grade math student in his
Yeah,
upcoming
that's right,
film.
he
Is that
is.
what it is?
Yeah, they got this whole reconstruction thing that's going to make him look 7 years old. It's really
Yeah,
cool.
well, hey,
Nice.
technology.
So
Either a giant head or very old-looking 7-year-old.
it says if angle 1 is 65 degrees, what are the other angles? And let me just, oh yeah. Okay, so it says if angle 1 is, let's see if I can get this. If angle 1 is 65 degrees, what are the other angles? And angle 1 is right here, as you can
Okay.
see right
and
there.
and you said it was 2 parallel lines.
Let's see here.
I mean, it looks like it.
Yeah,
Yeah.
parallel
We
lines cut by a
always want to
transverse
make sure
line.
that it's given. We don't want to just assume that just because it looks like it.
I always
But
tell
yeah.
my students, if I don't indicate that lines are parallel and they want to go ahead and write on there, like, I can't solve this because I don't know that these lines are parallel, I can't really argue that they're wrong, right? Like,
That's very true.
so if they make that argument, then that means they understand it living a little bit better. But if I don't tell them that lines M and N are parallel, then they can feel free to tell me that they can't solve that problem.
And they're right.
Yeah.
Even though they might not know. But it's true though. We don't
Yeah.
want to assume. We never really want to assume. A lot that to me I think holds true a lot for right angles. A lot of times people want to assume an
Right.
angle is a right angle just because
Yeah.
it looks like one. But so it has to be given in order to do that. So we were given this diagram where one of our angles was given. Now there are a few, would you call them postulates, I guess, or theorems?
Conjecture is what we're...
Conjectures, okay. Conjectures that state, that give us some information about the relationship between all of these angles. And I stole from the internet, of course, a couple of diagrams to illustrate this. So if you want to cut to my screen, here's an example of what we're talking about. We've got 2 parallel lines here, and then it's cut by a transversal, meaning it's 2 parallel lines and then there's a line going through it. One of the things that is known to be true is that corresponding angles are always equal. Corresponding angles, and I'll show you examples of those. So angle 1 and angle 5, those would be considered corresponding angles. Those are always equal to each other. Also, angle 2 and angle 6, and I should do those in a different color because they're not necessarily equal to angle 1 and angle 5. 2 and angle 6 are also equal to each other. And you might be able to see this visually too. You can kind of see that they are actually the same size angle. And then angle 3 and angle 7 are also equal to each other. I'm going to do them in yellow, and I'll explain why in just a minute, why I'm saying that they're yellow, the same. And then angle 4 and angle 8, I'm also going to put these in pink. Those are corresponding angles. Now, I put the 3 and 7 in yellow as well as 1 and 5 just because angle 1 and angle 3, so these two, those are considered vertical angles. They're across there, and they're also equal to each other. So we actually only have 2 different angle measurements in this whole configuration. So 4 of them are equal to each other, and then the other 4 will also be equal to each other. And I don't know, how important is it to you, Nathan, that your students remember the names or the types of angles that they are? Or is it more important just that
geometry,
they know?
I think it's pretty important. Like, I don't make everybody memorize, but they should be able to identify, especially as we get more into proofs. Like, they need to be able to say, angle 1 is congruent to angle 3
Because
they're vertical angles. And if you can't provide that proof, then it's hard to move forward.
Move
so
forward.
I make it
Understood.
pretty important they remember those.
Understood. You're right. With proofs, definitely. So then, and I'm just going to color code this. So alternate interior, we see those alternate interiors. Let me actually show you this. When we're talking about interior, we're talking about all of the angles that fall here. So 3, 4, 5, and 6. Those are all interior because they're kind of inside of the figure. And then exterior angles are on the outside. So if you're having trouble with that vocabulary, this is maybe one way to remember is that exterior, they would be on the two outsides, and then interior would be on the inside. And then alternate, meaning, so for example, 4 and 6 are alternate interior. They're on opposite sides of that transversal, so they're alternate. Vertical, again, are going to be, for example, here, on the same parallel line. So this vocabulary might be something that you want to work on memorizing because, as Nathan said, it is important with proofs. So that being said, we know that angle 1 and angle 3, they're going to be equal to each other because they are vertical angles. So we know our angle 1 is 65 degrees. So we'll also say our angle 3 is 65 degrees. And that's, again, because they're vertical angles. We also know, based on, I'll go back to here, we also know that corresponding angles are equal. So corresponding, like that, I'm circling them, angle 1 and angle 5. So our corresponding angles here, same idea, would actually be angle 1 and angle 5. So we know that those two angles are equivalent because they're corresponding angles. And that holds true also for angle 3 and angle 7. Those are also corresponding angles. And so those are now equivalent. We also know that angle 7 is equivalent because it's a vertical angle to angle 5. So you have multiple reasons why you know that they are equal to each other, but all you need is one reason. The other thing that we need to kind of consider is that, let's say we have a line and an angle like this. These two angles, I'm going to name them angle A and angle B. These two angles are called supplemental angles, which means that their sum is 180 degrees. Supplemental angles. So that means A plus B has to equal 180 degrees. And that's just because if we didn't have the line in there separating the two angles, then it would just be a straight line or an angle that's opening up all the way almost flat like that. So that would be 180 degrees. And so if we split them up that way, we just know that they have to add up to 180 degrees. So that being said, we know that angle 1 and angle 2, they are going to have to add up to equal 180. So we could say 65 degrees plus my angle 2, which is what I don't know, is equal to 180 degrees. I can solve this equation algebraically just by subtracting 65 degrees from both sides. And we get that angle 2 is going to be equal to 115 degrees. Now, this information is going to help us a lot because it can also then help us find the rest of the angles. So we have angle 2 is 115 degrees. And then from there, we know that angle 4 is going to be equivalent because it is a vertical angle to angle 2. So we'd say that's 115 degrees. We also know that angle 2 is a corresponding angle to angle 6. So it is 115 degrees. And then since we know angle 6, we also know angle 8 because those are vertical angles. So 115 degrees. So now we have all of our angles measured. And there are only 2 different measurements. Do you have anything to add to that? This is not normally, geometry is not normally what I teach, so do you have anything else you want to?
Yeah,
add to that?
I thought you did great with like the terminology. I know when I
Okay.
started teaching geometry, I was like, I know all this stuff, but I can't explain why. Like I
Right.
remember vertical
The
angles, I
words.
remember linear pairs or supplemental. That in geometry, especially if you're at this point right now, that terminology is very important to remember. I always try to tell students challenge themselves to like use the proper terminology whenever they can. Like stop yourself if you're saying like, oh, these are right next to each other. Like think about what that
Why?
term means. And I also want to talk about like really quickly. You mentioned like postulates, conjectures, things like that. The difference between conjecture
Let's talk about that.
and theorem, because and whenever you look at these like vertical angles or supplementary angles, we're going to talk about we'll talk about really quickly why those are called conjectures, and why we sometimes say, oh, this is a conjecture, but this is a theorem.
Okay.
You know, if you could pull up Becca's image really quick, what we could say is like the vertical angles and the linear pairs, like those are conjectures. And the reason is because they're not mathematically proven. You couldn't say, these are things that are like assumed to be true based on observations that we have. Like if you were to take angle 1 and angle 3 there and fold angle 1 onto angle 3, we could observe that those angles are exactly the same. Or we could test and add angle 1 to angle 2 over and over again, and you'll see every time it adds up to 180. But there hasn't been necessarily sometimes this like mathematical deductive proof of it happening. Whereas theorems, like they have proven it mathematically. Both of them we assume to be true, but one we know that has actually been proven mathematically. Which is why in Sherlock they're always like, oh, I deduced this happened because it had to have based on like all this other stuff.
Right.
So when you hear conjecture and you hear theorem, remember those two terms actually have slightly different meanings, although they do both mean that in math that we assume that whatever the property is to be true. It's just a matter of how we got to that proof and
It
how
makes
precise
sense.
we've been. So
I think that's important to note, and there are similarities in science as well. I know. So very interesting.
yeah.
Very interesting.